Hello and welcome to this video. Now we shall be deriving the indirect utility function and the expenditure function of a typical consumer from the Marshallians we have derived. So if you want to know where we got this direct utility function, you look at the previous video on how we derive the Marshallian demand functions using the Lagrangian approach. So we got this Marshallian from that video and these two from that video. So now we want to derive the indirect utility function. So for ease of simplicity and clarity, we denote the indirect utility function as V. So where V is simply equals to U. So instead of U, we replace it now with V. So this will be V is, of course, X half, Y half. So what next do we do? So we substitute X Marshallian and Y Marshallian into V, which is the indirect utility function that gives us the indirect utility. So how do we do this? So we call U is equals to X half. So instead of X, replace this because this is X Marshallian. This is Y Marshallian. So this gives you M over 2px half times Y. Y is this. So this gives you M over 2py half again. So, but this should be V rather, not U anymore. So this gives you V is equals to M half, right? Yeah. Over 2 raised to half. See, px raised to half. You can also say the square root of them. Times M raised to half over 2 raised to half py raised to half. So you have M half times M half. Because the bases are the same, both of them are M, so you can take one and add power. So you have M half plus half. So that's basically 1, just for clarity. So divided by, this is also 2 half, 2 half. So it's like 2 half plus half. Px half, py half. The bases are not the same, so you cannot add them. So you just leave them as that. So it becomes px half, py half. So this is the same as M over, this is half times half is 1, so M1. Then this is 2 half plus half gives you 2 px half py half. So this could also be written as M over 2 the root of px py. So that's your indirect utility function. So we want to derive the consumer's expenditure function from this indirect utility function. So it's easy. So for expenditure function, for expenditure, we denote M, which is in the utility function, as being equal to E. So this M now equivalent to E. So M is equal to E. This M now is equal to E. So the idea is that at optimal, the consumer is spending all of his income to purchase the good X and Y. So therefore, income is equal to the expenditure. Yeah, so income is equals to the expenditure due to the additive property of partially and demand functions. So, but we know that V, which is the consumer's indirect utility, is given as 2 EX half EY half. Hmm? So all you need to do is replace M here first. So you have V is E over 2 EX half. Hmm? And you have EY half. So if you want to solve for E, you cross multiply. So just by cross multiplying, you have E equals to 2V EX half PY half. Hmm? 2V PX half PY half. So basically, this is your expenditure function. Yeah. So whenever you want to solve for expenditure function, you solve for E. So when E is equals to 2VPX half PY half, that's your expenditure function. So you look out for the other video. We want to see how we explain the properties of the indirect utility function.